So, the subject is special electrical machines, and in this particular subject, we are going to discuss some special electrical machines which are different from the electrical machines that you have learned during the fourth semester of AKTU BTech in Electrical and Electronics Engineering, that is Electrical Machines 1, and during fifth semester of the same BTech course, that is Electrical Machines 2. In the subjects of Electrical Machines 1 and 2, what you have studied was the DC machines, DC motors, DC generators, transformers, and besides this, during the fifth semester of the course in subject Electrical Machines 2, you have studied the induction machine and the synchronous machine. So, majorly induction motor, only an introduction of induction generator principle, then synchronous machines. So, synchronous generators as well as synchronous motors, and besides this, the single phase machines. Those single phase machines were largely single phase induction motor, and along with that the universal motor and repulsion motor. That was the content of the subject of machine that you have gone earlier. Now, in the subject of special electrical machines, let us start with understanding what actually the special electrical machines are. So, the special electrical machines are a class of electrical machines that do not fall under the category of conventional machines like DC motors, induction motors, or the synchronous machines. These machines have unique operating principles, unique construction, as well as specific applications, making these machines suitable for specific purposes. We will discuss in detail what are the application areas of these special electrical machines. They are often used in advanced industrial, aerospace, automotive, and other cutting-edge fields. So, the special electrical machines are different from the conventional machines like DC machine, induction machine, and synchronous machine. They are the modified versions of the machines and with some unique constructional features. And you will find later on that these machines are fed by the power electronic converters to impart them the certain operation and the characteristics. They do possess unique construction, unique principle, and specific application areas. Common types of special electrical machines are, we do have stepper motors, we have brushless DC motors, we are having permanent magnet synchronous machine, PMSM machines, we are having switched reluctance motor, SRMs, we are having linear motors, hysteresis motors, and we are having doubly fed induction generators. Besides this, single excited induction generators also fall under the category of the special electrical machine, and it would be covered in the content of the syllabus of special electrical machine. So, what is special with these machines? What is special with these special electrical machines? They do possess high efficiency as compared to our conventional machines. They have the compact design, they are equipped with the enhanced control capabilities, they are sustainable, and they find specialized applications. High efficiency. Many special electrical machines like BLDC, PMSM, they offer very good energy efficiency compared to the traditional machines, making them ideal for applications where energy savings are critical. For example, their efficiency may range from 85% to 95%, right? Compact design. These machines are often smaller and lighter in weight, providing high power density, which is essential for many applications, and one among them is electric vehicles and another one are the drones. Besides many other applications which require small size machines but with higher power density. Enhanced control capabilities. These machines are designed for precise control And this precise control is crucial in robotics, in CNC machining and other applications which require precision and the accuracy. So these machines they possess the enhanced control capabilities. The control capabilities are imparted in the entire drive system. Sustainability. Many of these machines are aligned with modern trends in renewable energy system. For example, wind turbines. Wind turbines are equipped with usually these days doubly fed induction machines, induction generators, and other applications, and solar tracking system which may have the BLDC motors, contributing to green and sustainable technologies. So in that way, it can be said that these machines are aiding in the sustainable development or the energy transition. Specialized applications. They are tailored for specific requirements. They are specially constructed for specific requirements like high torque, low noise or high speed operations, making them indispensable in certain industries. Applications, general applications of special electrical machines. So what are the various areas where these special electrical machines are actually utilized? Industrial automation, which motors can be used. Stepper motors and BLDC motors are used in CNC machines, in robotics and automated conveyor systems. Electric vehicles, permanent magnet motors and switched reluctance motors are widely used along with BLDC. BLDC motors are widely used for electric vehicle applications. So please add here BLDC as well. Aerospace and defense applications, linear motors and hysteresis motors are utilized in aircraft system and missile guidance. Then comes the medical equipment. So precision motors are found in MRI machines, in robotic surgery devices and drug delivery systems. Automated drug delivery system inside the hospital. Some of the hospitals have started the automatic medicine delivery inside the hospital premises these days. Renewable energy. So doubly fed induction generators are used in wind turbines for efficient power generation. Then comes the application in consumer electronics. BLDC motors are commonly used in fans, compressors, washing machines. So besides this, BLDC also find application in electric vehicle, as I have told you earlier in the previous slide. Transportation system. So linear induction motors are applied in maglev trains and modern metro system. Why should we study these machines? Adapting to modern trends. With the increasing focus on sustainability, automation and renewable energy, these machines are becoming central to technological advancements. Because these advancements are using the technology are using special electrical machines for various applications. Solving industry challenges. These machines address challenges like energy efficiency, miniaturization and precision, which are critical for advanced engineering applications. Career opportunities. Knowledge of these machines open career prospects in industries like automotive, robotics, aerospace, renewable energy and consumer electronics and many more. Huge research potential exists in the field of special electrical machines. These machines offer extensive opportunities for research and development, especially in improving their design, their control and integration with the modern system. So a huge research potential exists, a lot of research is going on and a huge research potential exists in the field of special electrical machines. Broader application spectrum, they allow engineers to cater to niche applications and develop highly specialized solutions. Now let us go through the detailed application areas and various motors which are used in these applications, starting with the industrial automation. So, the stepper motors, the BLDC motors, switched reluctance motors. Stepper motors are used in CNC machines for precise positioning of the tools, applied in 3D printing as well for layer deposition, and utilized in pick and place robots in various manufacturing units. BLDC motors, they derive industrial fans, blowers and pumps. Due to their high efficiency and reliability, they find application in the automation system. They find the application in automation system over the previously developed application using the conventional machines. Serve in servo drives for industrial robotic arms, etc. So, BLDC motors are used for these purposes. Then we are having switched reluctance motors. They operate in high temperature industrial environments such as textile and chemical plants, where robust and simple designs are advantageous. The second one is electric vehicle. The second application area for these special electrical machines is electric vehicles. So, what are the various motors which are employed in electric vehicles? So, we are having permanent magnet synchronous motor. They are widely used in EVs. In Tesla electric vehicles, PMSM motors are being used, and they are employed because they possess high torque density and high energy efficiency. Then we are having brushless DC motors, power to drivetrain of the electric two-wheelers and scooters as well as in three-wheelers and four-wheelers, but they find the two-wheeler applications are dominated by BLDC motors. Then we are having SRM, so preferred for EV applications due to their rugged design, simple construction and ability to operate high temperature without magnets, and being without magnets is the biggest advantage of SRM, and here SRM find an upper edge as compared to the BLDC motors because they require permanent magnets, and the resources of permanent magnets are a bit limited. Then linear motors, they are applied in charging systems and electric railroads for the transportation. The next detailed application area is aerospace and defense, and the various motors which are employed are linear induction motors, then we are having stepper motors, then we are having BLDC motors and hysteresis motors. The hysteresis motors are basically a special type of single phase synchronous motor. So, used in launch system, which one? The linear induction motor, launch system for the aircraft and on aircraft carriers. Then stepper motors operate in satellite systems for solar panel orientation, basically for solar tracking and antenna positioning. BLDC motors found in unmanned aerial vehicles and drones for lightweight propulsion. Hysteresis motors, they ensure smooth and quiet operation in gyroscopic instruments and navigation systems. The next detailed application area, which is another very important application area for special electrical machines, is in medical equipment. So, stepper motors find application in medical equipments. Along with the stepper motors, BLDC motors and linear induction motors. Basically, linear actuators are based upon the principle of linear induction motor. They are also employed in the medical equipments. Then we are having renewable energy system, the system which is very much important in energy transition that we are dealing with, the world is dealing with this time. So, we are having doubly fed induction generators. They are essential in wind turbines for variable speed operation and efficient power generation, and the efficiency of doubly fed induction generator ranges between 85 to 95%. Linear motors, they are used in solar panel tracking systems to follow the sun's movement to capture the optimized energy for maximum power point tracking basically. Then we are having permanent magnet synchronous machine and BLDC motors. They drive hydroelectric generators and small scale wind turbines in hybrid renewable energy systems. The next very wide application area of the special electrical machines is in consumer electronics. So, in consumer electronics, BLDC motors, they are found in household applications like refrigerators, replacing the traditional single phase induction motor for better efficiency. Air conditioners, washing machines, ceiling fans. All these applications were conventionally the applications of single phase induction motors. So, BLDC motor in consumer electronics and household applications. In commercial applications, the BLDC motors are replacing the single phase induction motor for a better efficiency, compact size with higher power density and efficiency. Then we are having stepper motors. So, they drive camera autofocus mechanisms and DVD tray system of the player. Then we are having hysteresis motors. They are used in high fidelity turntables for audio playback due to their low noise and very smooth performance as compared to the other fractional kilowatt motors. Another one is transportation system. So, in transportation system, linear induction motors are there, SRMs are there, BLDC and PMSM motors are also there. So, the linear induction motors power maglev trains and the advanced metro system, providing frictionless and efficient propulsion. They are based upon the principle of magnetic levitation and they employ the linear induction motors. Then in transportation system, the use of SRM, they are used in electric buses and trucks for their ability to deliver high torque under varying load condition, and the advantage with SRMs is they do not employ the permanent magnets. Then we are having BLDC and PMSM motor. So, they are applied in electric bicycles and scooters, basically electric two-wheelers, for their compact design and higher efficiency. Then comes the another major application area of robotics. Various motors which are used in robotic systems are stepper motors, BLDC motors, PMSM motors. They are used in robotic arms for precise step-by-step motion in industrial and the medical robots for precise control. BLDC motors drive wheeled robots for fast and efficient movement. So, BLDCs are used for the movement of the robot. PMSM motors, they provide precise control and high torque in humanoid robots and robotic exoskeletons. So, these are the various detailed application areas of the special electrical machines. Another area is the agriculture. So, we are making the agriculture system more efficient and more sustainable in nature. So, the various motors which are used, BLDC motor, they derive precision farming equipments like automated trackers and the irrigation system. So, agriculture automation requires these special electrical machines. Then we are having stepper motor. They are used in automatic seed dispensers for uniform distribution of the seed throughout the land. Then we are having linear motors. They enable movement in robotic harvesting system for the fruits and the vegetables. Then advanced application in research and development. So, these motors find linear motors applied in particle accelerators for moving charged particles in straight line. PMSM motors, they are used in experimental high-speed trains and aircraft propulsion system under development level, under research level. So hysteresis motors, they are found in precision instruments for research laboratories where low noise and a steady torque are critical requirements. Textile and printing industry, the various motors which are used are the switched reluctance motors and the stepper motors. The switched reluctance motors are used in operating weaving machines and looms where variable speeds and highly reliable operation is necessary. Stepper motors, they are used in digital printing machine for high resolution printing. Construction and heavy machinery, another application area for the special electrical machines. So PMSM motors, they are used in driving construction cranes and hoists, offering high torque and efficiency. What is important in all these applications? All heavy machinery applications, the high torque, high power density, compact size. Switched reluctance motors, they power heavy duty industrial equipment like crushers and mills in mining and construction. So here they find application in construction and heavy machinery. So it was all about what are the special electrical machines, what are the basic application areas of special electrical machines, why these machines are important, and why one should study the machines. So as I said, it is the subject of special electrical machine and it is the very first lecture of the subject under the AKTU Electrical and Electronics, BTech Electrical and Electronics during 6th semester as a departmental elective. So let me just tell you, just remind you, this is the scheme and it is under the departmental elective 3. So special electrical machine, and the scheme is like this. You are having evaluation scheme, 30 marks internal and 70 marks external. It is a 3-credit subject. Let me just share the course outcomes of studying the subject of special electrical machines. The student would be able to describe working principle, constructional features of different type of electrical machines, including the fractional kilowatt applications as well. The student would be able to analyze torque speed characteristic of different special electrical machines. The student would study different types of control techniques for a machine and identify the best control strategy and illustrate the use of various motors like stepper, VLDC, SRM and other special machines in the area of various industrial as well as commercial applications involving the fractional kilowatt motors as well. So here they are actually replacing the already used fractional kilowatt motors, which was the single phase induction motor earlier. And this is the detailed syllabus. The subject comprises of 4 units. So unit 1 will basically cover the induction generator, self-excited induction generator, doubly fed induction generator, 2-phase servo motor, which is basically a specially designed 2-phase induction motor, and the linear induction motors. Then in unit 2 is dedicated to the stepper machines, various types of electrical machines, their drive circuits, their characteristics, their operation and various applications. Unit 3 is basically the switched reluctance motor. So complete switched reluctance motor along with its torque, its sensorless torque production, rotor positioning, various power electronic systems required for the operation of the switched reluctance motor or SRM, sensorless operation of the SRM, closed loop control operation of the SRM, etc. Then comes the unit 4, and unit 4 is basically the permanent magnet machines and BLDC motors. So I'll cover the entire, then we are having unit 5, and unit 5 is single phase synchronous motor, hysteresis motor, reluctance motor and the single phase commutator motors. So we will cover in upcoming lectures, we'll cover the entire syllabus of this subject, and in the next lecture of the subject, I'll start with Unit 1 and I'll start with the principle of induction generator, self-excited induction generator, doubly fed induction generator. So that's all for this lecture. Thank you.